Hello everyone and welcome on the virtual booth of FEIG Electronic. My name is Andreas Binder. I am responsible at FEIG Electronic for the product line of the mobile devices and wearables as well as for the market logistics. You have the possibility during the whole webinar to input your questions in the chat window. At the end of the webinar we will then give answers to your specific questions. But before starting, I would like to give the possibility to my colleague Daniel Buch to introduce himself and the company FEIG Electronic.
I'm responsible for sales of our stationary RFID equipment. This kind of products can be used in a wide scale of different logistics application and contributes to improve several processes significantly. FEIG Electronic is a medium-sized enterprise located in the center of Germany. We are developing and manufacturing all our products by our own within our facilities. So all products are 100% made in Germany. Within our company we are operating 4 different business units. We have a department developing industrial door controllers, one division taking care for traffic sensors, a payment division who is developing contactless payment terminals for unattended payment applications, and the sector of identification. Here we're taking care for different AutoID technologies like RFID and barcode. We can offer a wide range of different products for different frequency bands, stationary equipment as well as mobile devices.
Ladies and gentlemen, we don't want to bore you too much with a dry and theoretical show session. Instead, we have tried to build up some use cases which you know from your business processes. Beginning with an RFID gate, scanning items inbound and outbound automatically based on RFID. Then the singulating of the items from a pallet and store it into a storage shelf. Also item picking, so putting together items from a storage shelf into a box for a specific order. And also the supply of material to the production shelf, making sure that the right materials in the right shelf at the right time. And the end, of course, also an automated material call generated from the shelf itself based on RFID technology.
We are now in a typical doctor application. Here we have an RFID reader gate which consists of a UHF long-range reader and up to 4 connected antennas. The FEIG UHF long-range readers are specially designed for inventory of large tech populations. It is possible to do the inventory with a very high reading speed just within a couple of seconds. Typically in doctor applications, a large number of readers is active at the same time. A high interference rejection ensures that our readers will perform on a high level with a high sensitivity and high reading speed under all that conditions. In conjunction with the reader, we are using a special designed antenna. This antenna's core feature is a very focused reading angle. It enables us to minimize the risk of false positive reads due to objects that are moved by while the scan process is active. We're coming now to the live demonstration of our doctor application. So my colleague Andreas will execute the necessary actions and I will explain in detail to you what's happening next. We received already the shipment information from our supplier. Our ERP system knows which delivery is expected. In that particular case, we expect a shipment that consists out of 10 pieces. When Andreas is moving now our carrier through the gate, all the items on the carrier are identified and it's visualized to the worker that the delivery is complete. The system is also able to detect when a delivery is incomplete. To visualize this, my colleague Andreas will take one of the boxes and move it away. We're still expecting 10 pieces. And when he's moving now again through the gate, we detect only 9 out of 10 items. This is visualized on the screen by means of a red light and the worker knows that either one part is missing and can take the necessary actions. In comparison to the full automated process via RFID, we see here how much time it consumes to do a manual scan of every barcode via a handheld device. For tracking of objects within a building, we can offer a very special device. This is a reader with integrated antenna, which allows direction detection of a moved transponder. In logistics, it can help you to track your goods that are received from the doctor to the storage place, for example. The device is suitable for installation under the ceiling or on a wall. Next to the logistics sector, you can use it in a wide scale of different other applications, for example, for people tracking or for tracking of documents and other assets. In the following demonstration, we would like to show you the capabilities of our direction detection system. My colleague Andreas is carrying now one single box and he's moving along a corridor. When he's approaching to the system, the tag that is placed on the box is already identified, but the direction is not determined yet. In order to do so, he needs to pass by the reader system, and only in that way it can be probably calculated if it is an ingoing or outgoing movement. Here we see another member of our UHF long-range reader family. It is a very ruggedized compact reader that is suitable for direct outdoor use. It is specially designed for use in vehicle access control applications. So in logistics you can use it for fleet management or for opening of doors within a building. The reader is equipped with an integrated traffic light. In idle state, it shows blue light. If an invalid tag approaches, this is visualized by a red traffic light. A valid tag is shown to the driver by means of green traffic light.
After seeing how fast and performant RFID reading based on stationary RFID gates is working, we are coming to another product family of FEIG Electronic, which is the portable devices. The Hybrid Compact is a very small and light device. With 70 grams, it is very easy to be worn on the back of your hand. With the integrated barcode imager, you can scan one-dimensional and two-dimensional codes very easy. Also, RFID is supported, so you can have a hybrid device supporting barcode and RFID in one and the same device. A special feature of this device is the changeable battery. The battery is able to provide the device with power for more than 8 hours with 10,000 scans and permanent connection. Equipped with 4 LEDs, a buzzer and a vibration, you can at any time give signals back to the user, even in very loud environments. On the communication side, the device supports Bluetooth and Wi-Fi communication. On the Bluetooth end, it provides HID and SPP profile. On the other side, you can integrate it by Wi-Fi directly in your existing Wi-Fi infrastructure. Supporting 2.45 and 5 GHz Wi-Fi frequency and enterprise authentication with supporting client certificates, it can be integrated even in Wi-Fi infrastructures where a high security level is recommended. With the seamless roaming function, the device can move from one Wi-Fi cell to another without losing the connection to the host. How easy data capturing can be with the Hybrid Compact, we will show you now in our next use case, which is singulating the pallet that we have inbound received through our RFID gate and putting the material on the right place in our storage shelf. The Hybrid Compact is worn like a glove with a very flexible material. It is very comfortable to wear. With a trigger between thumb and index finger, it is very easy to start a scan. Now, scanning one of the items that we have received, we'll get a green signal that it is an item that is already known in our system. Putting the item into the shelf, scanning the shelf number, and connecting the material with the shelf number in our system. Scanning the next one, again green LED, putting it into the shelf and connecting again the material with the shelf number. Now scanning the next one, let's assume we are putting it into a wrong place and scan the shelf number, which is already occupied through another material. We get a red LED so that the user knows that this action was wrong. So we know that this place is not the right one for this material. So we scan the right place. We get the green LED again, so that we know that this action has been successfully. The next scan. So you can see how easy it is to handle material with both hands. So in total we have a time saving up to 4 seconds per scan. Now we are coming to our next use case, which is the item picking. I have equipped myself with a smartwatch, which is running an app connected by Bluetooth to my eyewear, so that every scan is transferred to the app running on the smartwatch, and the smartwatch is connected to our host system. On a smartwatch, as a user, I can see which item should be picked for my active order. I start scanning item 444, get a message on the display of my smartwatch that it is the correct item for this order. The next one, scanning the item. Oh, this was the wrong item, so get signalized, and also the message on my smartwatch that it was the wrong item. So need to pick 555. This one is correct for this order, so I can take it, put it on my pallet. Next one is 158. Same for this one. And there is one more to pick. It's this one. Also successfully. Order is complete now. I get the message on my smartwatch, so I have picked all items which are belonging to this specific order. In our next use case, we will supply the item picks from the storage shelf to the production shelf. Supplying material to a production shelf needs to make sure that the right materials in the right shelf at the right place, so that the worker on the production site can follow his used movements. Therefore, we are scanning the material. We are getting a feedback that it's the right material for this shelf. Put it into a shelf, scan the shelf number to check if it's correct. We are getting a red signal. It means that this material is in the wrong shelf. Change the position, scan the shelf number. Green LED signalizes that we have the right item. So, we are getting here bad signal, must be for another shelf. So let's scan this one. Green LED again. Placing it into the shelf. Shelf number is corresponding, so the material is correct. With our last use case for this session, we want to demonstrate to you an automated material call based on RFID. As a worker on the production site, I'm producing the items I have to produce, so I'm taking material out of the box. Some when the box is empty, so I'm taking this box and putting it below the shelf. Our MRU 102 is automatically reading the RFID tag attached to the box, generating a material call in our system so that the item picker can pick the new item and providing this shelf with the correct item within the next few minutes, so that we as a worker can continue our work without any interruption. Thanks to the flexible material of the cuff, it can easily be worn on different types of working gloves, or even without, as I do it on my hand. Of course, the cuff is also available in 3 different sizes and for right-hand or left-hand users.
Beside the products we have seen in the different presentations, FEIG Electronic can offer a wide scale of different other products. Within the UHF sector we have various mid-range readers, reader modules and antennas. A similar product range is available for HF technology. Next to this, we have a product family which is called MyAccess. Here we are offering different solutions for people and vehicle access control.
Even on the mobile product range, we offer a much broader range of products than just the wearable. With the Echo Plus and Scandi hybrid devices, which combines barcode and RFID in one device, or the PRH 102, which has an integrated HF and UHF reader for specific applications.
Herewith we have reached already the end of our today's presentation. We are happy to continue now discussions with you and to answer your question.